Hello, I would like to speak with you tonight about some old school equipment that I've got. It is precise equipment, and so we're going to be doing some measurements with it. So I wanted to walk you through some basics of it before we actually take some data. So this is called an oscilloscope, and I'm just going to show you a couple of the features of the oscilloscope. First off, I want to show you this cool knob here, which is called time per division. And so I'm going to click this thing down and give you a sense of what's really happening here, what this knob is all about. So notice on the screen here that we've got these vertical lines, and these are called divisions, and there's 10 of them across the whole screen. Now what the signal does is it starts at a certain point on the left side here, and it crosses that first one, and if we count to see how long it takes to go across the finish line, because it's 0.2 seconds per division, it would take 2 seconds to get across the entire screen. Well, I'll change the knob up to 0.1 seconds per division. Now it goes across in 1 second, and it starts over again, and it keeps doing the same thing over and over again. Switch it further up, 50 milliseconds per division, 20 milliseconds, 10 milliseconds. Now it's going across every 1/10 of a second, and so on and so forth. And I can keep going the whole way, and this is cool because I'm essentially controlling time with this, and I think that's pretty neat. So that's one of the basics of the oscilloscope. We're also going to be using this device over here, which is called a signal generator or a function generator. And right now you'll see what it does here in a second. When I hook the oscilloscope, when I hook the signal up to the oscilloscope, and what I've got up here basically is that I've jury-rigged this thing to kind of split the signal. So the signal comes out of here and it's split. Some of it goes to the speaker and some of it's going to go to the oscilloscope. So let's turn up the volume and see what we got. Change it to sine wave here. Okay, so you notice on the screen that I've got a sine wave, and it's old school, so it's a little rough of a sine wave. I also have, you also notice it's kind of flickering a little bit. So I got this knob called the trigger knob, and basically this just tells it where to start the signal. So I might occasionally reach up here to adjust this. And again, I'm not changing the signal itself, I'm just changing how it looks on here so that we can make better measurements. Alright, so let's find out what this knob does. This is called the frequency knob, and right now I've got it, I can go up to 10, I can go down to 4 and 3, but wait, 3 what? Well, right now it's set on the 100 hertz, and so I can click it to this one, which is 1000. And now we go up to 1000 hertz. Now it would be 3000 hertz, whereas before it was 300. I'll come back down a little bit so it's not quite so annoying. Notice I've got a whole bunch of full periods on the screen, so I can pull down the number of, I can change the time axis so that we can see more detail. And again, higher frequency, higher pitch, lower frequency, longer period, lower pitch. Let's go back down to this range. I kind of like 800. That seems kind of like a pretty good place to be. Change that volts, the time per division. And one other knob here, I can change the sensitivity by seeing how many volts per division we've got. So basically, I have a couple of different controls. I can also move the signal around. For instance, if I want to start this period at this tick mark, at this line, I can move it horizontally. I can also move the signal vertically. There is a horizontal line that has some tick marks in it to make my measurements even a little bit more precise. So between these devices, these are the kinds of things that we can do, and this is the data that you're going to be looking at.